Have you ever thought about a world where robots aren't just stuck in factories, but are actually helping out in our homes, our hospitals, maybe even on other planets? Well, that world is getting closer every single day. And today, we're taking a guided tour of the incredible tech that's making it all happen, physical AI. So, what does it really take to build a robot that can see and think and act in our world? This isn't just a question for sci-fi writers anymore. As AI gets smarter and smarter, the big challenge isn't just about the code, it's about embodiment. How do you give these amazing digital brains a body that can deal with our messy, unpredictable physical world? Well, the answer lies in a field called physical AI. And here's a simple way to think about it. Your brain is the software, right? And your body is the hardware that lets you move around and interact with things. Physical AI is all about doing the exact same thing for machines. It's about giving software a body. To really get a handle on this, we're going to break it down into 5 key stops. First, we'll look at why this is the next big frontier in tech. Then, I'll lay out a learning roadmap for you. We'll get into the essential toolkit every roboticist needs. Then, the fun part, giving robots a mind. And finally, we'll talk about the future that you, yes you, can help build. For decades, AI has been kind of trapped behind our screens, just crunching data, making predictions. But we are right on the edge of a new era, an era where that intelligence is breaking free from the digital cage and literally stepping into our physical world. This isn't just about smarter software anymore. It's about software with hands and legs and the ability to interact with the world, just like we do. Just think about it for a second. Robots that can help the elderly live independently at home. Robots that can perform incredibly delicate surgeries with a precision that no human can match. Or even robots that explore dangerous places that are just too risky for people. That's the promise of embodied AI, and that future is being built as we speak. Okay, so how do we actually get from here to there? It's not about some single magic breakthrough. It's a systematic journey of learning and building piece by piece. And that's exactly what we're going to dive into next, a clear, step-by-step roadmap for anyone who wants to become a builder in this new robotic future. Think of this 6-step journey as your guide to the world of robotics. Each step really builds on the one before it, taking you from the absolute basics all the way to creating some seriously complex, intelligent systems. So let's start at the beginning. All right, so you wouldn't try to build a house without a solid foundation, right? It's the same exact thing with robots. You can't build one without mastering a few key pieces of tech first. In this first part, we're going to explore the 3 pillars of modern robotics: the operating system, the virtual testing grounds, and the powerful AI platforms that give you a head start. First up is the unsung hero of the robotics world, ROS2. That stands for Robot Operating System. Basically, it's an open-source framework that acts like a universal translator for all the robot's different parts. The camera, the motors, the sensors, you name it. It lets them all talk to each other. Without it, you'd have to write custom code for literally everything, and trust me, that would be an absolute nightmare. That's why it's the industry standard. Okay, once you've got your robot's nervous system sorted with ROS2, it's time to bring it to life. But not in the real world. Not yet. This is where simulation is absolutely crucial. Simulators like Gazebo and Unity let you test your robot's design, its code, its AI, everything in a safe virtual playground where mistakes cost you nothing and you can test new ideas super fast. Now, what if you could kind of skip ahead and not have to build everything from scratch? That's where platforms like NVIDIA Isaac are a total game changer. Think of it as this incredible toolkit that comes packed with pre-built AI modules for really complex stuff like perception and navigation. It's like starting a race halfway to the finish line. It gives you a massive, massive advantage. So, with that foundational toolkit locked in, we can move on to the most exciting part, giving our robot a mind. The next 2 steps on our roadmap are all about that intelligence layer, the software that turns a pile of motors and sensors into a truly smart, autonomous agent. Step 4 is where some of the real magic happens. We're talking about vision, language, action models, or VLA for short. These models are what connect what a robot sees with its cameras to what it hears from us and then to what it does with its body. So when you say something like, hey, pick up the red ball, the VLA model lets the robot actually see the red ball, understand your command, and then physically pick it up. It's this beautiful, seamless loop of perception, language, and action. But look, we're not just trying to build robots that can follow simple orders. The real goal, the holy grail, is to create robots we can interact with just as naturally as we talk to another person.
And that means moving beyond simple commands into real two-way conversations. Imagine a robot that can ask you a question if it's confused or remember what you talked about yesterday. That is the future of human-robot collaboration. And that brings us to the final step on our journey, putting it all together. This is where it all clicks. This is where you take all those individual skills and technologies you've learned and you weave them together into a single, functional, and intelligent robot. A capstone project is the ultimate test, right? It's where you use ROS2 to actually control the robot's arms and legs. You'll use Gazebo to build a realistic virtual home to test it in. You'll use the Isaac platform for advanced perception so it can recognize things. And of course, you'll use VLA models so it can understand and respond to your commands. It's that incredible feeling when you see all the pieces finally snap together to create a truly intelligent machine. So we've walked through this whole journey, from the basic tools to the cutting-edge AI. But that really brings us to the big question, the most important question of all. Why does any of this matter? In a world with so much new technology popping up every day, why should you focus your energy on physical AI? Well, the answer is simple. The future of technology is physical. For years, we've been building up this amazing digital world, but now is the time to bring all that AI power out into our physical world. The demand for people who know how to do this is absolutely exploding. And this isn't just about building cool gadgets, it's about solving some of the biggest challenges that humanity faces. You have an opportunity to be right at the center of this incredible revolution. So look, the roadmap is clear. The tools are more powerful and easier to access than they have ever been before. And the world is literally waiting for the next generation of builders and innovators to step up. The only question left is, what will you build?